In this video, we're going to use the quadratic formula to solve quadratic equations. We'll also talk about how the discriminant, the piece under the square root, can be used to tell us the number and type of solution. So example 1, first find the discriminant for the quadratic equation below and identify the number and nature of the solutions. Then use the quadratic formula to find the solution. Before we can find the solution, before we can use the quadratic formula, we need to make sure this is in standard form. So ax squared plus bx plus c equals 0. So this way we can identify a, b, and c. So we can add 1 to both sides. So a is 1, b is -6, and c is 1. So remember, when a number is not written in front of a variable, it's considered to be 1. So first we want to find the discriminant. Or b squared minus 4ac. So b is -6 minus 4ac. -6 squared, 36. -4 times 1 is -4. Or 32. And we can see from our given graph that this has 2 real solutions. So let's use the quadratic formula to find the solutions, and we'll see how the discriminant gives us the 2 real solutions. So minus b, or minus 6, plus or minus the square root of our discriminant, which we found is 32, all over 2a, or 2 times 1. So to simplify, minus 6, positive 6, plus or minus the square root of 32, or 32 is, let's say that's 16 times 2. 2 times 1 is 2. Square root of 16 is 4. So it's 6 plus or minus 4 root 2 over 2. Now this piece can be simplified more. I can write it as 6 over 2 plus or minus 4 root 2 over 2. It's common denominator, but add across the top. So it's like taking the common denominator and working backwards. 6 divided by 2 is 3, plus or minus 4 divided by 2 is 2, root 2. So we can see when our discriminant is a positive number, this plus or minus will force us to have 2 solutions. All right, so example 2, go through the same steps. So first we want to find the discriminant. So I need to put this in standard form. So take away 8x from both sides. So a is 1, b is minus 8, and c is 16. So b squared minus 4ac. Negative 8 squared, 64. Then negative 4 times 1 is 4, times 16, minus 64. 64 minus 64 is 0. And we can see from our given graph that that has one real solution. All right, so let's finish the quadratic formula. So x is equal to minus b, which is minus 8, plus or minus the square root of our discriminant, which we found was 0, over 2a. So simplify. Minus a minus 8 is positive 8. Plus or minus the square root of 0 is 0. 2 times 1 is 2. Well, 8 plus 0 is 8, and 8 minus 0 is 8. So this is the same as 8 over 2, or 4. So we can see when the discriminant is 0, it gives us the same solution twice, which is the same as having one solution. All right, one more example. We'll see the last case. So again, let's find the discriminant first. It's already in standard form. So a is minus 2, b is minus 4, c is minus 8. So b squared minus 4ac. So negative 4 times negative 4, 16. Negative 4 times negative 2 is positive 8. 8 times negative 8, minus 64. 16 minus 64 is negative 48. And then we can see from our given graph, it does not cross our x-axis. So we have no real solutions. All right, so we'll finish the quadratic formula and see how a negative under the root or negative discriminant will give us our no real solutions. X is equal to minus b, which is minus 4, plus or minus the square root of our discriminant, which we found is minus 48, over 2a. So let's simplify. Minus a minus 4, plus or minus. I can take care of the negative under the root, bringing out an I. And then negative 48, that's 16 times 3, all over 2 times negative 2 minus 4. Square root of 16 is 4. 3 stays under the root. Then I can split this up to simplify. So 4 over minus 4 plus or minus 4I root 3 over minus 4. 4 divided by negative 4 minus 1. This piece is a little strange, but we can think a positive and a negative make a negative. Negative and a negative make a positive. So we end up still having a plus or minus. 4 divided by 4 is 1. I root 3. So there's no real solutions when we have a negative under the discriminant because it gives us an imaginary, or in this case, a complex number. So we have two non-real solutions.